Hi there, my name's Josh, and this morning I got really ambitious. I was like, you know what? I'm gonna upgrade my PC. So I stuck as much RAM as I could, and I want to show you the results. Here we go. It's fascinating. I was able to stick probably about 20 gigabytes of RAM in here. All sorts of technologies, all sorts of different speeds, capacities, power requirements, and no surprise it doesn't work. And I don't want you to end up in that situation where you're all excited about an upgrade and you buy the part, it comes in and it doesn't work. So we're gonna go through 10 things to make sure your computer upgrade as far as RAM goes well. And these are gonna be things to look for and decisions you'll have to make when you buy RAM. First one is, are you buying for a desktop or a laptop? Makes a ton of difference when you're dealing with sticks that are small. This is called a SO-DIMM, and sticks that are big. This is called a DIMM. They're very different and you can't mix and match. While the technologies might be the same, there might be DDR3 this and DDR4 that, you cannot mix them. It just doesn't work. Now there are some edge cases when you're dealing with tiny mini ITX boards. They may take a laptop sized RAM, but that is usually an exception rather than the rule. For any of these, I recommend you just open it up, see what's inside, see how big it is. Next one is DDR3 and DDR4. If you're working with a slightly older system, think maybe 3 or 4 years ago, you'll likely run into using DDR3 sticks. These are getting harder to find as they're not in production anymore. They are not on sale anymore. People don't have them a lot, so the prices are starting to go up. If you know a local computer shop who has like a whole bunch of them and is about ready to throw them away because they're useless, try to get a hold of them. They might part with them pretty easily. Number 3, is there a slot available in the motherboard? For this one, it only has 2 slots. For desktops, this will be pretty obvious. But if you are buying RAM for a laptop, the answer might not be so obvious. Try to look up images of the motherboard. If your laptop has like that cool back panel that comes off to only expose the RAM, that might be something you could look into. I know for my laptop, I had to take off the entire back panel and I was able to see that, oh, I do have 2 slots. So I put in another 8 gigabyte stick and it worked. I know for a lot of Ultrabooks, they do not have that extra slot. It's just 1 slot, and that can be a very big problem if you are trying to double the RAM. Instead of buying, another 8 gig stick, you would have to buy a 16 gigabyte stick and replace it. Number 4, let's look at our CPU. This is actually very crucial and just, pun intended, crucial, get it? They make memory. So the CPU is very crucial in deciding what memory to get. This CPU has a memory controller built into it. A memory controller is a piece of circuitry that communicates between the processor and the memory. So whenever the processor needs some data to be fed into it, it will fetch it from memory and spit it to the processor. This is a very good in-between guy because they are both running at different speeds. One is in the gigahertz and another is in the megahertz. Or, well, I guess they're getting to the gigahertz now, but there's a huge speed disparity and a memory controller is crucial. And that memory controller will decide a lot of things. It will decide how much memory it can address. It will decide if it wants server memory or not. It will decide how many banks or channels it will support. Lots of information can be found simply by looking up your processor nowadays. Also, fun fact, they have graphics cards on these too. It's crazy, these little chips. I mentioned it briefly, but ECC memory is a thing. This stands for Error Correcting Code Memory. This is able to correct memory errors on the fly, and we normally only see this in server level computers. Now, a server is not the Gigabyte A320 $50 motherboard. Those motherboards for servers usually start at $300. The chips are like tens of thousands of dollars. It's big money. And if you have to ask if you need ECC or not, well, you probably shouldn't be buying it. You should go ask someone else. This will usually apply for the memory controllers on the Xeon processors, on AMD EPYC, AMD Threadripper, and yeah, that's about it. It's a very slim pickings when you go into ECC memory and the number of different ones that are there. ECC memory is usually more expensive, at least 12% more expensive. There's less of it being made, and it physically looks different. It will have extra DIMMs on it. It'll be arranged in a different way. It's just different technologies. It is not compatible with a standard memory controller on, say the Intel 2500K, 5500K, 1050K, 10500K, whatever generation. The Core i series is very different from the Xeon series when it comes to memory support. 6, let us look into the motherboard of the computer. So I said to look at it physically, and that can tell you a lot of stuff, just looking at it. But Gigabyte has been so nice to create pages and pages of documents that details what memory they support, how many channels support, how to do the channels, and tons of stuff I'll never read because I find it boring. But it is useful if you're deciding what memory to get, and if you're doing a special configuration, such as mixing manufacturers, mixing speeds, and mixing channels. So how do you know if I put an 8 here and a 4 here, if it'll run in dual channel? Check your motherboard documentation. That is a very quick way to figure that out. And once again, I got ahead of myself. Dual channel, triple channel, and quad channel memory is something that is supported by memory controllers on the processor again, and you will find it on the motherboard as well. This one has 4 banks here, if you can see past all of the shenanigans. Although it has 4 banks, it's really only a dual channel board. It'll have a channel A, a channel B, and channel A will have 2 banks. And it's even labeled here real small. DIMM A1, DIMM A2, and then there's DIMM B1 and DIMM B2. There's really only 2 channels of support here, even though there are 4 banks. So there's channels, there's banks, there's slots. Knowing the difference between all these things and looking at the motherboard, it will help you out a lot. Check out your documentation, check out your processor, and when in doubt, just post on the forums. Someone out there has done what you're trying to do, I guarantee it. 8 is the motherboard again, but it is the BIOS of the motherboard. This is the basic input-output system. This is a program that drives all the settings, all of the support, and it will also support how your processor is talking to your memory. You're able to change settings such as, I want you to communicate at a faster speed than you're rated to. I need you to communicate only in single channel mode, or I want you to disable certain features of the memory. The motherboard BIOS can do that. And I know for this one, this is a 2666 megahertz DDR4 chip. If I install this, by default, it might run at 2133 megahertz, way below its rated specification. So what to do is get into the BIOS, tell it to run something called XMP, Extended Memory Profile, set the custom multiplier to equal to 2666, and now you have RAM speed running at what it should be. I've seen it very common to see like really good 6, but the BIOS isn't configured, and it's like, oh man, there's so much extra speed that you can just squeeze out of this thing. Do it! 9, this is kind of awkward, but people still rock Windows XP. I don't know why. This is mainly used for legacy stuff. Maybe you're trying to create a game box for old stuff. But for anything with Windows XP or Windows 7 32-bit or Windows Vista 32-bit, oh, it feels dirty. Okay, hold on, I need to get a drink. Vista was garbage. When you run into a 32-bit operating system, it can only support 4 gigabytes of RAM. And some of that is even used for hardware and drivers and stuff. So using 4 gigabytes, it can be a rough time when you're trying to run a large application. Even just opening up Microsoft Word nowadays, my gosh, that's a bloated program. It doesn't make sense to buy an 8 gig stick for a 32-bit system, and it will only be able to use 4. The rest of it, it's invisible. That is because the memory controller is a 32-bit memory controller. which means a 32-bit unsigned value, that's 4 billion addresses, that's 4 gigabytes. It is unable to send a call for the 5th billion or the 6 billion address space because it's limited by 32-bit addressing mode. That is a TLDR, it can't do it. You won't see that nowadays, if I'm honest. All DDR4 boards I've seen, they're running a 64-bit operating system. Although you theoretically could, get a 32-bit Linux OS and slap it on there and it might work. 10, and that is, does your motherboard have a low power variant? This creates a lot of problems. It's something I've only seen recently in the past 5 years. I'm so glad it's here. If we can create more energy efficient computers, that's awesome. But if I try to use this with a PC3L stick, by the way, this is PC3, it won't work. Something won't work, I guarantee it. That's because this is rated to run at, I think, 1.5 volts, and this PC3L might be 1.2 volts. Well, if I try to feed the 1.5 to the 1.2 volt chip, it'd be no good. And if I try to feed 1.2 to the 1.5 chip, that's not enough. Not enough to create the performance specifications and basically the JDEC standard of DDR3. You can't modify that without having shenanigans happen. And you don't want that to happen when you're playing a game or trying to do anything productive with computers. So, keep an eye out for low power variants. You can read on the stick if it says PC3L or PC4L or DDR4L or LPDDR4. That is a low power variant. Don't mix it with a normal chip and you'll be fine. One last thing about LPDDR is it's usually what you find in embedded applications. Cameraman, can you bring me your iPad, phone, that stuff? It's in these small devices where power and energy saving, it's a huge thing. Here we have a Huawei P30 Lite. So this, it obviously doesn't have these kind of sticks in there. That would be a little awkward. So what this does is it will bake the DDR4 chip directly onto the little board in there. So you'll have like the Qualcomm chip and then you'll have like a small RAM chip and like it's all on there, it's embedded, it's low power. This phone, the battery life lasts forever. Forever. I've never charged it since I got it 9 months ago. Not really, but that's kind of how it feels. And the same for, we just got this last week, iPad 4th generation. This has an embedded RAM on it. I can't take it out of the board. As much as I would love to, I can't. It's just not gonna happen. So, yeah. I wanted to share that with you. It's cool to see these technologies be ported onto devices such as this. It's very nice. Though the downside is you can't upgrade them. Once they're made, it's baked on there, it's not coming out. And when you're working with some Ultrabooks, you'll run into that problem where it's there. Also, pretty much all MacBook devices nowadays the RAM is on the board, it doesn't come out. Alrighty, that was 10 things. I hope you've learned, and if you watch this video and end up with some kind of monstrosity like this, like putting your RAM in the CPU, it's a problem. I have a video for that, by the way, how to put RAM into the computer. I don't want you to end up with this. I want you to have a system that works really well. And if you're gonna spend money buying parts for it, it should work really well. So take these decisions whenever you're buying a new product for your system and RAM related. This will really help you get started and figure out what the best product is for your device. I'm Josh here. I hope you learned something about RAM today. Join me along for this adventure as we learn about computers and how they work. And today we talked about RAM, but there's so many other systems to go over. Subscribe, follow along on this journey. Drop a like too if you liked it. I hope you liked it. I hope they liked it. What if they didn't like it? Bye. Bye. Well, bye.